Okay, well, welcome to this session, which is Lava for LITE platforms and tests, and I'm Bill Fletcher. This session material came out of a meeting with LITE in the last Connect, where I was asked to prepare some tutorial material, mainly for, well, not primarily even, but specifically for getting people who hadn't used Lava in LITE up to speed. Now we've got quite a mixed audience here. How many people from LITE here? Sir, you are our most honoured guest.
Oh. Yeah, I'm sorry for being late.
That's fine. It's he's really relieved.
I just saw what by Lava and Matt.
Yeah, I was just explaining that this was the material here is what came out of the tutorial discussion with Vicky at the last Connect. So it's quite introductory. It was run as an internal BlueJeans session, and it's repeatable in that format or whatever. Is there anybody here who's from LITE who's not used Lava before? Okay. All right. Okay. Makes it quite interesting, really, because some people may get a lot of email done in this session, then. But I'm okay with that. So I'll go through this material anyway. If anybody wants to pitch in with great wisdom from the heights that some people have achieved, that's fantastic. It's specific to LITE. The emphasis is on Zephyr targets, that is to say things that don't run Linux and don't have shells. Out of scope is installing a local instance, so the material assumes that you're running on the Lava lab. And also out of scope is it assumes that you're running devices that are already supported, and you're not looking for features that aren't already there. It would be great to run a session on that, but this wasn't in scope for this session. A sort of rough idea of the contents is on the right-hand side. So Lava overview and test job basics, which is going to be interesting for some of you. Getting started with the Lava lab instance, which, well, I mean, you could actually stand up and give this one. Anatomy of a test job, looking at Lava results and writing tests. I have got a couple of slides on invoking Lava via XML RPC, which I could have used it on the last session, but and then a couple of, again, introductory stuff on metadata and job templates, and given the audience, maybe we'll go quickly and get onto that stuff. And then we fall off the end, and some of you will still have not worked up a sweat. So I don't know what we do there, but it's the last training session of Connect, so maybe we can just have a little fun. I don't know if anybody thought of kind of going backwards and thinking that Lava should be short for something else. See, I guess it was originally the Linaro automated validation architecture, but people are very keen on backronyms these days. No? Maybe for those of you who know all about this stuff can spend this session trying to think of another thing that could stand for. Well, it's something clean.
You could just all lowercase it and then pretend Linaro never existed, kind of like HKG.
Well,
do you have any suggestions?
I'm just curious, So what Lava is, all the documentation is online. I think we've been saying that in every Lava session. The documentation is online, and I think the documentation is really good. And I say that from somebody who's not in the Lava team. So you should go to the link, you should read the docs, and the docs.
I found two bugs. When I started my LITE work, I found two bugs only in documentation, but it was fixed, so yeah, documentation is great now.
There you go. This is unsolicited testimonials, all going on video on the internet.
Yeah, I'll hear that 10 later.
Okay, and this is just the standard how lava's put together in the documentation. So this is the master, the workers, the web interface, the dispatcher where all the exciting action happens. So this slide has a few terms that people will get referred to time and time again, but I think it's really important that people understand the concept of the dispatcher, because the dispatcher is the thing that actually interacts with your target. It's the part of lava that's connected. And this is particularly for Maria. So, as I say, the dispatcher is the part which is connected. Just for those of you who don't make it to Cambridge often, here are some boards in the lab, beautifully cabled by probably Luca.
Yeah, he came up with a model, and it was a joint effort to get all of them in.
I think we all had our hands in there at some point.
And some of us are blood.
Okay.
I think all of us.
So in this example, a dispatcher provides Ethernet, console, USB, control of whatever mode the board is in, and power control. And the dispatcher needs to be able to put the device in a known state, deploy the test image, boot the device, exactly monitor what's happening in the test, otherwise lava wouldn't be lava, and then put the device back in a known state. Again, for people who are new to lava, lava test jobs are called a pipeline of actions. And there are 3 types of actions. Still only 3. Deploy, boot, and test. Deploy downloads the files that are required by the job to the dispatcher. Boot, as it says on the tin, boots the device. And test, again, as it says on the tin, executes the required test. So, if you look at a test job file, it'll have those elements listed. It'll have a deploy action, it'll have a boot action, a test action. The deploy action will have an image URL, basically the URL that the job is going to go to get the Zephyr image. The boot is going to specify a boot method, and test is going to monitor whatever patterns you're expecting to come out of the test. The word monitor is quite important. But I guess a key thing which came out of the discussions that we had at the previous Connect was that if you've got a complicated job, you can build a more complicated pipeline. For instance, you can have sequential test actions because maybe you're looking for different things. The monitor in an individual test action is not very flexible, but you can chain them, so you could look for maybe some measurements in one test action, you could look for a pass-fail verdict in another test action. And also, if you've got a test, a particular set of tests that don't fit into device memory in one image, you could actually build multiple images and deploy them sequentially, but then collect all the results as one job. So you're not ending up then having to sort of tie together multiple jobs to find out whether or not your test suite passed or not. So this is just an example of the fact that you can have a job pipeline for one job, but which has multiple actions. I don't know if there are many examples of that in the documentation. Because I think for LITE it was actually quite interesting to be able to offer that flexibility for either for memory constraints or because you don't have test shells, you've got to take whatever comes out of the test. And therefore being able to have multiple test actions is possibly slightly more interesting to LITE people. This is kind of documentation work. I won't dwell on this slide, but it's like, you know, maybe it's just to say that the action concept is pretty tightly defined. Actions don't overlap. Actions don't do things that you don't expect. Nothing happens except with an action. I have throughout this presentation, and obviously the deck will be up on SlideShare. There's this example which I use, which is one of the standard kernel common tests in Zephyr, and it's just an example that you can use. The image is already built, so you can actually submit the job to the lab, and you can see the results. So on the subject of the lab, Dave, Maria, and Luca's handiwork is here for you to see. This is what the Cambridge lab actually looks like. And actually, I can ask Dave, are these figures still correct? How many workers?
So we now have more micro instances.
That's no good to me as an answer to the question. How many
I'm
workers?
just trying to work it out. We're probably up to the realms of about 11 or 12 workers now.
All right, okay. And how many devices? Because I can only see public devices.
Yeah, so in total about 150.
Right.
Yeah, that's what Neil and I worked out.
Right. Okay. So the validation.linaro.org instance is 150 devices, 12 dispatchers, and it's this kind of thing.
Well, the validation is not 12 dispatchers anymore. You have the QEMU dispatchers, but the physical dispatchers is only 5, is it that? Or is it
No, we've got 6.
yeah.
But in VLO, but if you then go to LKFT, you've got 4.
Exactly, yeah. But yeah.
Okay, many.
Amongst the dispatchers.
Yes. Okay. So the web interface. So I guess a couple of key points. The web interface. You can submit a job via the web interface. I don't know if that still works.
Yes.
Yeah, you can.
Okay. And so you can basically paste the YAML in and it will run. You can view all the jobs, you can view all the active devices and some other stuff. So authentication tokens. Should I do this live maybe?
Ooh, is it?
No fair. So once you've asked Dave for a login.
No, you can LDAP login. Once
Okay.
So we just use LDAP authentication.
Okay.
You
So
don't have any rights to submit yet.
so you still have to ask.
Until you can submit.
So you have to wait. You have to email me, ping me, say, "Can I submit jobs, please?" And I go, "No."
So I was right. You have to email Dave.
You have to email.
Email Dave, and then he.
But you can.
Or ticket, surely.
No, you email Dave. You've got to know. You've got to have a personal
It
relationship.
honestly takes about 2 seconds.
Oh, sure.
But
I'm doing this with my
if you
friend.
email the entire Lava team,
It's Lava Lab team.
yeah, it's easiest.
My presentation just said email Dave, and I think that we'll stick with that. Okay. And once you've emailed Dave, and once Dave has said you can submit jobs, you still can't submit jobs unless you have an authentication token, which once you've logged.
You can from the UI.
Oh yeah, okay, right. But
But
as
as a remote user.
a grunt,
Yeah.
you need an authentication token, and an authentication token is something that looks like that.
Take a picture.
That's what, go on, compromise me. I do it, yeah.
That's true. Come on.
There was a question.
Does it not support to LDAP?
There's the way.
LDAP?
Yes.
Yeah.
Yes, yes.
Yes, well,
Supports LDAP, but you have to have permission.
As long as you've got a Linaro email address, you can log in.
in our, you can set up your own.
I mean, you set up your own, yeah.
Without the actual knowledge.
You can also have just local users. You don't have to use LDAP.
Okay, so once you have the authentication token, then you need to know how to get support. So at this point, I guess it's useful just to have the distinction between the Lava Lab, which is the physical instance. So if you have a problem with infrastructure, then it's Dave. And support portal and report a problem. And if conversely, the Lava project, I have Neil standing, Steve. So that's the project. So Lava the lab and Lava the project are two distinct entities, each with their different charms. So submitting jobs from the command line. One way to do this, I said the command line tool for interacting, a command line tool. Lava tool can be installed inside the Debian-based distribution, allows a user to interact with any Lava instance. It's for manual tasks, uses keyring integration, and I've put it's quickly outgrown because, to be honest, do many people use Lava tool now? Right, okay. Because everything you can do in Lava tool, you can do in XML RPC, and you don't have to install Lava tool, right? So even if you are a relatively naive Python developer, it's actually preferable to use XML RPC, I think. But Lava tool is a good way to get started.
Yeah, so Lava tool, and there is a newer version of the command line tool called Lava CLI, are great if you want to do interaction on the command line. Please, please, please do not use those if you're scripting things. You know, they're there for direct interaction. If you're scripting, do it in XML RPC. That's all these do on the back end anyway.
Yes, so I mean that's probably something that came from the previous session, is what about API support. So Lava tool auth add to add your token, Lava tool submit job, or actually, he said zipping through that material. You can do the same as basically 10 lines of Python with the submitting the token, and that does the same thing. So so this is basically just the steps to submit a job. All the links are here. I'm not assuming that you would do it live, but I will do it live. Assuming I can find my terminal window. Did I close my terminal? No, I don't. So this is submitting a Lava job by the command line. So I have my job file on my PC. There it is, the same file that I put up with its actions for deploy, boot, and test. It's running the image has got the kernel common Zephyr test suite. I just submitted it to Lava. And there's the job running. Takes about 20 seconds. Oh, it's done, and it passed. That's not what I wanted. And that's the result. That's running a Zephyr job in Lava. And interestingly, the slide deck has got a bunch of goes through the output in significant amount of detail. But a couple of points to note is that it says test suite and it says passes and fails. 11 passes, no fails. Total's great. But also interestingly, there's a Lava test suite, which is actually the checks and tests that Lava does. So the output of the test results not only tells you what your test suite did, but it also tells you what Lava did. And if I click on test suite, you can see just some of the things that Lava did when it was running your job. So it validated your job first of all before it ran it. during the deploy phase, it did an HTTP download of your image. It rebooted your board. It started the monitor. It powered off, and generally, it has an aggregate. It says the job passed. I think it's more interesting when some of those fail, because then you have to figure out what went wrong. So that's submitting a Lava test job. I'm happy to go through in some detail, or the documentation goes through in some detail, what the anatomy of a test job. The deploy action is probably quite interesting and mystifying to people from LITE, because the deploy action is incredibly simple. You just give it a URL, and it's basically go and get that. And I guess it's maybe worth saying that Lava does a whole ton of clever stuff in deploy for jobs that aren't Zephyr based, related to test overlays and putting together multiple parts of images. But for Zephyr, it's just basically downloading your monolithic image to some temporary location to put it on the target. Boot action, boot method, CMSys, or PyOCD, or obviously QEMU if you're running a virtual target, are supported. Since we have all the Lava gurus here, you can specify PyOCD or you can specify CMSys, but you can't specify any parameters. It's just whatever the device has got coded in the device type. Is that right?
What would you want to specify?
I'll take that as a no.
Yeah, what would you want to specify? I mean, the parameters are just where the device is, so Lava knows how to flash it.
For this original tutorial, one of the things that was interesting was flashing MCD boot images. So you might want to change boot addresses, you might want to change flashing addresses and that kind of thing. There's no progress towards that sort of tweakery then.
Yeah, with the PyOCD stuff, it's all in the deploy action. When you list the images you want to flash, you can put more than one. I can't remember how you do it offhand. And then you can change the frequency options per image you want to flash it at as well, and things like that.
Right. Okay.
Because people are flashing up things other than just the Zephyr binary.
Right. Okay. So there are some more things that potentially to play with. I don't know if that's anything that you or David have used.
David's not here, but as far as I know, that's still on his wish list.
Yeah.
To be able to deploy particular binary to particular person. So we're still waiting for that.
Yeah, and if you can't do it, ask me and I can add it, because it should just be a sort of, because we just build the PyOCD command line. If I could just make it a device configurable or job configurable option, we just have to add it into the PyOCD command line, so that should be quite easy. So if it doesn't do what you need, put in a support ticket and I can add the support.
Sorry, Jen, behind you have a question.
What would be required to support other boot method like OpenOCD?
That's the next way of flashing that I'm working on at the moment. The problem has showed up that some people are using custom versions of OpenOCD, so you can't just use the one that's like installed in Debian or something like that. So sad. I mean, and you can't run more than one together at the same time because they interfere with each other. So there's a bit of trouble. But OpenOCD is the next method I'm looking at.
And when?
I'm not agreeing to any timescales right now, but I'm supposed to get it working by the end of the month. So that's whether that ticket will slip a bit because of Connect, but it's this month's work.
Cool. Okay, and then just for completeness, the test action, and I guess all the excitement is really in the line that I've highlighted in yellow, which is the sort of matching string using sort of extended Python pattern matching syntax. Is everybody familiar with that? Yeah. If you're not familiar with it, then and you're writing tests for Zephyr, then you need to get familiar with it fairly quickly. And the other thing is, I guess the monitors. It's an action. It's a class. But it's the way that Lava monitors the output of a test without any interaction. So obviously you're not running a shell. Lava doesn't pass commands back. It just basically takes whatever is coming out of the serial port. So I guess the question would be whether that is enough for the tests that LITE guys want to do.
It's that's good enough. So, there is a feature request to be able to do more interactive testing, like feed something into the board and watch for result. Yeah, but we were replied that well, this way has issues and it's a bit hard to implement, and it was previously implemented for Cortex-A based boards, but it was short after that. So. Well, as this feature request comes from me, I'm trying to look from that point of view and trying to move tests to this, you run everything like a non-interactive manner, just output everything. So now that feature request is still active, but yeah, it's not high priority, at least for JavaScript script testing is still on to do, but for MicroPython I was able to convert test to this to output only mode.
So basically making all tests into kind of a fall through type.
Yeah. So we went to Lava to follow its way.
Right. So I'm going to skip over this section because we already looked at some of the output, but in plenty of detail you can see where the parsing is happening and what happens if you look into the job details. You can see what is matching in terms of those patterns. I think one thing that's may still not show up is the actual end pattern match. You know that it matches start for the monitor, but when you have end, it doesn't show up.
It does now. So you'll get it, the job will finish because it's seen it, but just because of the way pexpect and our logging works, the job will finish, or the tests will go, oh, I finished, and then you'll actually get a line near the end of the job which just shows any output that was left over from the board.
Okay.
So it appears down the bottom, it's a lighter grey colour because it's not interesting text by that point because you've already finished your testing, but it is now in the job file.
Okay, because it's nice to be able to grab through the job file and find that it did actually happen at all. So you're saying it is in there, but it's out of sequence.
Yeah, it's just right at the bottom.
Right.
A lot of people don't see it because they see the test bit finishing, but actually it's because Lava's finished the test at that point, but underneath it, you can see it.
Yeah, but that's a bit confusing for somebody who just starts with Lava. So if you guys have a chance to fix it somehow, it would be nice. It would be appreciated.
Well, I think to echo what Paul's saying, for a lot of people, they really don't care. But as I mentioned before, for LITE guys, if you're having to chain together a lot of test actions because all your tests are fall through, you don't have a shell, you can't tweak the output, then and you're trying to debug this, you want to know when stuff hits the end condition and then starts the next one, and having to figure out that it'll happen at the bottom is probably a bit clunky.
Why have we started from the position that Zephyr doesn't have a shell?
Because I know nothing about Zephyr when someone said, please make Zephyr run in Lava. And what I based it on is the fact that all of the tests, the sanity tests that are built into Zephyr, just start up, dump out text. We parse them as best we can. I know it has because it's Zephyr could be anything. You could write your shell into it if you want to. So no, there isn't we don't call. I know we're saying this is Zephyr, but it's not. This is just the Zephyr tests. So somewhere down the line, if you want to start writing apps on top of it, I wouldn't call that Zephyr. That would be your app you're trying to test.
and Zephyr has a directory called shell with some stuff in it, but I think shell is kind of a reserved word.
There's actually a Zephyr test that produces a shell.
Which you can't test without.
Yeah.
Okay, so one other thing, job timing. So you can get this cool graph, which I guess my point here is that it's not really for performance, but it is useful to see just how much sandbagging you've got in your timeouts for versus what your job actually takes to execute, particularly if you've got issues of devices being hung up in the lab. This was again something that from the tutorial. This is maybe something for people to look at if they do want to write a test job. So this was using two chained test actions to parse some output which had some output value parameter values. So for boot timing. So basically, there's a job definition that has a test action that matches first of all the start action, the start and the number, and then a second test action that matches the pass main. So there you've got a test with two test actions. And one thing was that I was really pleased when I actually managed to write this and it did actually match and give the numbers, because it did feel like quite an achievement. But one thing that I would use this to highlight is that it makes a lot of assumptions about just the format of those lines, and if somebody just changed that test a little bit, that would break in a way that probably doesn't happen for Linux users of Lava. So the clever you get with crafting these things, the more fragile they become, and whether there's some way that you can actually start to move these patterns into metadata, so that you save them with the in the repo with that version of the test, rather than having hard coded tests with patterns, which then when you'll be always running to fix one and then the other.
Aren't you just restating we don't recommend using run command, which is in the docs for the adult version of for Lava when it's running on big targets? There's still the recommendation: don't do continual run command scripts. Please instead have a shell command that runs the whole test all at once. Which is why I was asking the question: if you were trying to do microcontroller tests, why you wouldn't follow the same advice and patterns that have been developed
You mean
with big machines?
By using a shell?
Well, that would be the obvious thing to do, or you just you bake it into the app. But
Yes.
yeah, what you're saying with the difficulty of writing monitors is exactly the same thing as the difficulty of writing run command scripts.
But the other thing is that a lot of people in LITE are trying to rerun existing test suites, and so they're sort of like caught between two stools. They don't have the Linux flexibility to wrap those in something. And at the same time, they still have to put up with whatever arbitrary output comes out.
Yeah, I agree. Although it's a young project, and if you could get it baked into the idea that there was a particular type of string that would prefix a result, we used to use hat in my old companies, but it doesn't really matter if the project as a whole had a recommendation of how the output comes out, so that scripts are considered, the tests are consistent. We've done a lot of work to get these things consistent.
Yes, essentially. We are trying to adjust for Lava recommendations, but it's not always possible because we have constraints. Like we sometimes can't even put more textual output because it can overflow flash or something like that. So we are trying, but we may hit some issues and come back to you guys.
Yeah, understood. The thing that other test suite people are trying to go for, there is a standard TAP 13, which is great if you want to be parsing test start, stop, and output and whatever. If you guys could have a look and use the same, it might make your lives much easier.
Page tab 13, service tests.
Okay. So that was kind of my high watermark in writing tests. I'll move on. So this is kind of a bit saying in words what the message that I just mentioned about things being quite fragile, or I mean the other thing is that, you know, I still advocate that obviously QEMU support for Cortex M is available, and there's just a plug for QEMU support for V8M is now available. So it's actually like people who want to use V8M who don't have V8M boards. I don't know anybody who has a V8M board. Then you can use QEMU. And the advantage of QEMU is that it doesn't tie up any resources, and everything is nice and virtual. So that's kind of where I was trying to get to, as running as the tutorial material. I had just a few further topics, since we have such an erudite audience. So if you're new, then you can just buttonhole any of the people sitting in the front here, and they will solve your every problem.
Hey Bill, can I just, for the pattern parsing in the monitor jobs, writing those regular expressions is really hard. I mean,
Yes.
I struggle with that. But there is actually a website called pythex.org, which does Python regular expressions. So you put in your text you want to try and parse out, and then you can sit and play around with the regex until you get the pattern matching you want. That I have to use that every time because it's incredibly difficult to make it work in Lava.
I agree. I think they are hard. You get a real sense of achievement when you do actually manage to match something.
Yeah.
The other thing is just to write a Python program and have the output of your test as a file, and then run your Python program on that and debug it that way before you even get near Lava.
Yeah, maybe we need to add that to the documentation. Like, example, go here if you want to try it, or here's a good way of trying it.
I think that will be very useful because, again, I think that, you know, for existing test suites, and I take point for what Dan said, that if you've got control of the test suite, then you can make it easy for yourself.
I'm making the point that Erwin and Paul have influence over the test suites that exist. Quite strong influence. So.
Yeah. Okay. Well, great. So, but otherwise, you are dependent on being able to craft beautiful Python regex expressions.
Your expressions are hard.
Yeah.
Everyone knows it.
Okay, so a couple of other things. I think they're slightly out of order. So in jobs you can put metadata to put variables in that you can then populate and tie up so that you can relate what happened. You know what a job actually relates to in terms of build out URL, toolchain, board name, which Git commit you're testing. Which is very important, obviously, as part of a CI system. And you know, pretty soon you end up submitting a lot of jobs and then trying to work out which job was which. A sort of allied to that is creating a job file on the fly, because once you maybe decide that you've outgrown Lava tool and so you're going to use scripting to generate jobs, then you might as well at that point then be using a job template. So instead of, as well as the metadata, you know, even something as simple as your test URL and your test name being variables that you populate via templates. And as I mentioned, maybe also considering doing that for your pattern matching stuff as well. And then finally, the example that I just flashed to at the start, which is XML RPC, which is pretty much I figure it's actually at least as easy as using the command line. So to be honest, why would you persevere with that unless somebody wants to do a plug for Lava CLI Lava?
Steve just begs us not to use it. Steve begs us not to use it.
Don't you?
So by all means use it if you're playing around with things, but don't use it if you're scripting things. Yeah.
What, Lava CLI?
Yeah.
Why?
Lava CLI and Lava Tool. Because at that point you're then fighting around, the point of those is they are wrappers around the XML RPC. You can go and have a look at the code, but you then end up fighting against, you know, what they're trying to do in terms of managing your authentication tokens and that kind of stuff. If you're going to use Lava from your own automation stuff, if you're going to drive things from Jenkins and that kind of thing, please just use the XML RPC.
Sorry.
It's the right answer.
I use Lava CLI as an admin tool.
Oh, absolutely. As an admin tool, it's great, but don't use it from your own scripting.
So what I'd suggest now, with kind of perfect timing in at least one case, is that we throw the floor open to a discussion.
I've got a new acronym for you. An acronym. Linaro allocates variable acronyms.
Glad I didn't quite get there with the microphone.
So am I.
All right, so the floor's open. So we have, you know, a good chunk of Lava ninjas, Vikings, however you want to be called.
May I, or should somebody else knock a go? I noticed the word Zephyr burnt into the JSON, and there's nothing here that is any sense tying it to Zephyr. It is just a microcontroller deployment. Every firmware I've ever written can be tested with this thing if it had shell support. And
no, because you'd have to call it Zephyr, otherwise it wouldn't work.
No, I didn't try it, no. Yeah, you can come next. The other one is run command support coming? Because that does make a big difference for testing microcontroller apps.
I actually can't remember if there's a ticket open to do it. I don't think it's... I'm interested when you said your, like, the initial reply you got was that it's almost impossible or it's extremely hard or something like that. I don't remember being that conversation or being in it, so I'm wondering if to approach it again and see if it isn't as hard as has been apparently told. So maybe if there isn't a ticket, then we'll open one, because if it's something you need, it's something we should be doing, basically.
Okay, yeah, so I opened such a ticket for like interactive testing for quite long ago. It was just waiting for scheduling. So, well, essentially my impression, so I used to work on Lava some time ago. Now I am approaching, I also worked with people who work on Lava here and from there. Now I work with Lava directly on from the other side. And well, there is definitely like some issue with initial adoption. Like I'm trying to use Lava for more or less new thing, and there are a lot of small things which, well, confusing or weird or something. So I tried to report them, like those last line is not showing. It actually initially confusing. Then you learn about it and get used to it. But yeah, I'm in position to report it back and point it out, and such small things make work much more comfortable. Otherwise, yeah, I'm trying to learn, and for example, yeah, that interactive testing, it's also very good for initial startup with Lava. I don't know, like, I'm not sure that I would write 100 test cases like that. No, probably no, I would write it like in this, like, batched testing. So it's, I just thought it's kind of similar request like I heard previously, and which was implemented for dropping into interactive session when test fails. I remember it was a request from Android theme, from kernel, you know, it doesn't scale. You can't run all boards in that way because it will block it, but it's useful. It's an interactive input, and then check it is also the same kind of thing. Yeah. It's probably possible to get around without it. For example, I try to adopt, but yeah, it would be nice to implement. It's not high priority. It's not high priority. Yeah, and just yeah, so I thought that, well, I should not wait while Lava gets new features. I should try to So first of all, currently Lava is very well configured to run native Zephyr tests. So they run automatically, and we add new test to Zephyr, it can be run like that. But we also would like to test other things like applications built on top of Zephyr. And yeah, I had to struggle to run MicroPython test suite in Lava. Fairly speaking, probably half of that struggling was on MicroPython side. I thought we still pretty flexible test suite, but to make it run with Lava, I had to make quite a bunch of adjustments still. So it's like, yeah, Lava could not work with that way, that format which used by MicroPython, so I had made adjustments. There were also issues on Zephyr side. Yeah, it always happens because you see it's microcontrollers, it's a bit different. So there are constraints like flash size, etc. And I hit those like my binary was too big. But it was failing tests, and actually when I filled it out, everything which cannot pass in this configuration with Zephyr, it went just on the right side. So I did not had to resolve that issues, how to split testing into binaries or something. And actually, I'm glad to hear that it's possible, like Bill said, to have it by 1.1. So that's my feedback of trying to use. So it works. Actually, we are currently on that stage that we have like more or less good usage of Lava. Actually, there are still things to do on our side. But yeah, now questions from me is, yeah, so we need two things probably going forward. One is implemented more features, like for example, this interactive testing, but it's not high priority. But David Brown, he's not here, but he's, as far as I know, still waiting on being able to deploy a few images at once. It's required for like MCU boot, and it's like official way to do upgrades, so it's important. So like we just need to be able to specify offset binary, offset binary, offset binary. And another is we probably, I'm not sure we are still yet ready for that, but we would need to go with like network testing, like being able to talk with outside. So are you guys, it's probably for Lava Lab people, are you guys ready? Can you plug Ethernet cables into Freedom boards, for example? Or maybe they are already plugged, or how much time would it take
Freedom
to?
boards.
Yeah, so the K64F has got an onboard Ethernet
Alright.
socket, so yeah, plugging it in is trivial.
Yeah.
You can do it anytime. Great. So when we are ready for that, we'll be asking for that. Yeah, and one maybe personal question. So we used to host Arduino 101 boards in Lava Lab, and then they were like put away. What happened?
They retired when we moved to V2 because unfortunately they were not reliable in the lab.
I can only sigh. I find it a bit sad. Well, especially that it's not ARM board, it's Intel board. Yeah, and you see, Intel people in Zephyr, they do some things like paying additional attention for ARM ports, for example. They care about them. They have them in their CI. And it's a bit sad to see them go from our CIs. It's helpful to have another architecture.
Paul, put a ticket in. And
Yeah. We would happily have them. We would happily have them in the lab if we knew that they could work reliably, and if we know that they will be used. Because the problem we had was that it locked up after an amount of tests that was arbitrary. So until a new health check was run, it failed all the tests, and then it failed the health check, and then you had to let it wait for a while, and then it could be started again. And it wasn't stable in that way. But if we know that it needs to be used, we can see if we can find a way to make it stable, because we would like to help.
Yeah, just put a ticket in.
Okay, so I'm not in authority to request it, but yeah, I will keep it in mind. Yeah. So.
Dave just gave you authority.
Yeah.
Okay, thank you.
Just to answer Daniel's question earlier, there isn't a hard code to Zephyr. That's just the name.
Yeah, that's what I mean. Yeah,
So
it's
when,
like a misname.
yeah, but it's just in the job you say like, oh, this is an image I want to flash, and you can call it Zephyr if you want. You could call it Daniel if you like.
How many people
Oh, is that from text? Yes.
Yeah, it's
It was indented on a line on its own.
yeah, it's in the deploy step. You just happen to like this Earl, go get this binary. I'm going to call it the image Zephyr.
Yeah, but the 2 lines above that was an outdented line word Zephyr.
Yeah, it's not a deploy step. It's not a boot step.
Oh, you missed this clip.
Yeah, sorry.
So I assure you, it's not hard coded part of Lava. Yeah.
You understand? Yeah.
I just wanted to mention we took a different approach to having embedded boards in our setup because monitors weren't going to do it for us. We wanted to interact with the boards, and so what we ended up doing is we used the LXC path, and we create LXC containers, and each container points to a TTY USB, which has the actual embedded board that's responsible for that test. And so we write all the test cases in Linux, in Python or Perl or whatever, and it just, each one's given the TTY USB, and then it just talks to that one, gets the results back, uses the Lava test shell and all the same Lava stuff that any other AP kind of or Cortex-A kind of board uses, and we're doing multi-node testing this way too.
Yeah, I believe Neil suggested me this way. Yeah, I believe Neil Williamson suggested me this way when I asked for this like interactive testing. Well, I'm not like experienced Lava guy. I used to work it, but it evolved much after that. Maybe that's actually a good way to do multi-node testing, etc. But yeah, I guess it would take some effort to bootstrap. So again, if we had
some patches that we have.
Yeah, yes. If we had some template to start with, some sample, it probably would help.
Yeah,
absolutely.
If you reckon you need patches, or especially if you've got good example jobs, if you're prepared to share them with us, we'll happily stick them in the docs and and add them to what we recommend people to do officially.
Yeah, we had to do a few changes to the Lava dispatcher, particularly things like the PyOCD boot to make it work under LXC containers and a few other things like that. So it doesn't work out of the box. You've got to get those patches that we're using. But once you do that, then you just define the LXC job, and then you just have the test case in there.
Yeah, patches welcome, please. That sounds good.
One question. Once OpenOCD will work, we'll be glad to test STM32 boards. So when it will work, is there a limit for you in terms of number of boards to be used? For instance, we have around 30 STM32 boards in Zephyr. What if I send the 30 boards to you? Would you be able to set them up?
Please don't send them to me. But
it all depends. So if you want to send it to the Lava Lab, it depends on what kind of connection they need. If they need to be at the same place, if they need to have 1, 2, 3 USB cables, we can accommodate it. With the one thing that we've had problems with so far is if you want wireless connections to it, it might be interfering with things. But if you want to send us 30 boards that you think will be used for testing, and you've got a well-defined way for us to connect to them, we will accommodate that. And we might create a new micro-instance for you, but we will be able to accommodate it as long as it's, a form factor which is not huge.
These are small boards in general, and they have all the same connector type. So
it sounds good. Yeah, definitely. So the way to do it is you send a ticket to the Lava Lab and you say that we would like to create this with these boards. Can you set that up, and then we'll send you some questions on how you want us to do that, and then we have some Lava integration, and then we, if it is suitable and if it is stable, it'll happen.
Okay, thanks.
Yeah, thanks, guys.
Cool. Thanks everyone. Yeah, Bill's had to run. Definitely talk to us either through LDTS or directly on the Lava users list on IRC, whatever. We're happy to help with all the newer use cases, with extra boards, all that stuff. Hopefully it's useful.